Hello everyone. In this video, we are going to discuss about the exercise 4.1, that is from the questions 11 to 13, 11, 12 and 13 from the chapter 4 complex numbers and quadratic equations class 11 maths. See, we have already discussed about the first 10 questions from this exercise 4.1 in our previous video, which is available in the playlist. And we will be discussing the question number 14th in the next video, that is also available in the playlist. So here we are discussing about the question 11, 12 and 13. So see the question number 11. See, the question is we want to find the multiplicative inverse of each of the complex numbers given in this exercises. So you see, we want to find out the multiplicative inverse. See, if z is a complex number, z is equal to a plus ib, then its multiplicative inverse is 1 by z. 1 by z can be written as a by a square plus b square plus I into minus b by a square plus b square, or you can write it as this plus and minus becomes minus, so you can write like this as well, that is 1 by z is equal to a by a square plus b square minus I into b by a square plus b square. Okay, so z is a complex number, 1 by z is its multiplicative inverse. So first question, the question number 11, we want to write the multiplicative inverse of this 4 minus 3i, this complex number. So here the complex number z is equal to 4 minus 3i. So when you compare this with this complex number, z is equal to a plus ib. See, a is equal to 4 and what about b? B is equal to minus 3, no? Okay, a plus ib. So this is like plus minus 3 into I. Okay, so b is equal to minus 3. So the multiplicative inverse, which is 1 by z, that can also be written as z inverse like this. That is equal to a by a square plus b square. So a is 4 by a square plus b square. Okay, minus I into b by a square plus b square. So b is minus 3 divided by a square plus b square. Okay, now this becomes 4 by, okay, 4 square is 16 minus 3 whole square, minus square plus 3 square 9 minus, and this minus becomes plus, so 3 by again 16 plus 9. So this is equal to 4 by 25 plus, I'm sorry, one I is here. Okay, so I into 3 by 25. Okay, so you see this is the multiplicative inverse of this complex number, 4 by 25 plus I into 3 by 25. Now let us write the multiplicative inverse of this complex number, which is question number 12, root 5 plus 3i. Okay, so you see here the complex number z is equal to root 5 plus I into 3 or 3 into I. When you compare it with this complex number a plus ib, it is clear that a is equal to root 5 and b is equal to 3. Okay, then multiplicative inverse of z is 1 by z, which can also be written as z inverse, that is equal to a by a square plus b square. So root 5 by root 5 all square plus b square, that is 3 square, minus I into b by a square plus b square. B is 3. So 3 by root 5 all square plus 3 square. Okay, now this can be written as root 5 divided by root 5 square is 5, 3 square 9 minus I into 3 by the same thing, 5 plus 9. You can just take the common, you cannot take the common denominator because this is the imaginary part, no? Otherwise also you can take the common denominator, no problem, but we are writing it separately, that's all, common denominator. So here you see this inverse is equal to root 5 divided by 5 plus 9, which is 14, minus I into 3 by 14. Okay, so you see this is the multiplicative inverse of this complex number. Now the next one is the complex number is minus I. That is z is equal to minus I, which can be written as 0 plus, okay, minus I. Or you can write it as 0 plus I into minus 1. So when you compare it with this complex number a plus I into b, you see a is equal to 0 here and b is equal to minus 1 here. Then its multiplicative inverse z inverse is equal to a by a square plus b square minus I into b by a square plus b square. So here its multiplicative inverse z inverse, that can be written as a, which is 0 divided by a square plus b square. So 0 square plus minus 1 all square minus I into b, which is minus 1 divided by 0 square plus minus 1 all square. So this can be written as 0 divided by 0 plus minus 1 all square is plus 1. 0 plus 1 is 1. Minus into minus plus it becomes plus. So I into I divided by or I into 1 divided by, this is like 0 square 0 plus minus 1 all square, minus 1 all square is 1. 0 plus 1 is 1. Okay, so this is equal to 0 divided by 1 is 0 plus I into 1 divided by 1, 1. So I into 1, or you can write it as 0 plus I. So you see this is the 0 plus I, or you can simply write it as I. So you see I is the multiplicative inverse of minus I. Okay, so in this video we have just discussed the questions 11 to 13 from this exercise 4.1. We will be discussing the 14th question in the next video. I hope it is clear to you. Thank you.